Okay, boys, so I finished making the Archimedes pulley last time. You can see it here. Um, it's all these strings and little pulleys. And those lead all the way up to the finger, which will be able to bend when the motor actuates. And we got our winch in place pulley right here. This is our motor for that finger. And now I'm actually making a spring mechanism for returning the finger back to straight again. So that's going to be this spring here. I decided to mount it on the motor because that way I don't need a dedicated spot to put on my springs. I'll just put it on the motor that it's doing the spring return for. And so that kind of worked out nicely. I realized generally because these springs are so long and skinny, they'll always be able to fit on every motor somewhere between the two motors that it's paired next to right here. So I basically just tied off the string to the spring and then put a little bit of 401 glue. It's called a tension spring. If it's going to focus, that would be nice. There we go. So I taught off the string to each side, and now I can just pull on it, and it pulls tension. And I'll run this orange line through tubing, just like I ran the tubing off the motor here. I'll just follow the same routing too. So that'll simplify routing planning by just following the routing the motor uses and then just wrapping it around to the other side of the joint. So instead of the front side of the finger, it'll just wrap around the finger, near the finger. It can do that switch with the routing. But for the routing past the elbow joint and stuff, I could just follow the same as pattern, just swooping out and then back this way. So yeah, that's my solution for the return spring. And that will also keep the pulley strings nice and taut and tight in this area, and also this winch in place pulley here. The return spring will keep tension on the whole system, so the string won't want to unravel or get tangled. It will stay nice and firm and taut at all times. I'm just going to be listening to some productivity music. I just typed in maximum productivity music. Listen to that while I work. Okay. Let's see. Right now the spring travels freely back and forward. I want to like pin the top of it like right here and then pull out a diagonal down this way. So I need to tie it off in that direction. Okay. This ballpark is fine. Oh, man. Trying to visualize the routing. Which is hard to do. Is this string even long enough? This may not be. Oh no. Wait, is it? Hmm. You know what? I don't think it's good enough. I think the strings are enough. Let's see. It's not. We gotta change the spring on this spring. Change the string on the spring. Okay. I guess we're done with this for the moment. I originally was planning to have the spring, the return spring, a lot closer to the hand, but I just don't know where I'll have space for all those springs. There's something that need to be like possibly 40 of them. So just putting a couple springs per motor on the motor just kind of gets the springs out of the way of maybe key areas that I would rather put electronics and stuff for the hands. Okay, so man, I'm gonna need my magnifying headwear for this. It's getting tiny again. This is delicate stuff. Okay, give us some string. Okay. Okay, first one. Scissors. Yeah. All right. String. Sure. All right. Okay. All right. This time I can't do what I did last time because I unraveled it. Uh, Right, I put it through the spring on the other side of the little glued off section to the spring coils so that it cannot escape off the end of the spring where it's cut. Even just determining the length of this spring was tricky. I had to like test different lengths until I found one that had a good amount of tension for the and the correct draw distance capable without completely ruining the spring. The shorter the better though for tension created. Like a really long spring would take like it would just keep drawing and drawing out. We don't want that. So we want it short and stubby as possible. Come on. Why does it not want to pull through? There we go. Got it. Okay. Okay, I got it. Okay. Whew. I'll thread it through our Teflon tubing. Oh my goodness. Struggling a little bit. There, that's a nice clean cut. Alright, now it'll thread easier. I think you guys could be like right here. Got him. Just feeding it through now. No. I don't think it's. Oh, absolutely. Okay. Okay. Okay, just wrap some fabric tape around it. Now I want to sew the fabric tape on tight, and then sew that to the bone sleeve. It's so funny, like, every time I work on these, it's like I'm doing surgery. It's hard. This robot's the hardest project ever, man. Sorry. No! It's all approved. That's nice. Oh, no, this. Oh, okay. Good. Okay. That's, that's fine. Oh, that's good. Okay, sorry. I'm going to see. Yeah. That's perfect. That's got to be perfect. It feels like about 3 pounds. That's about perfect. It's just what I wanted. Okay. Wow, this is crazy. I can't believe I'm doing this. The backside of the fingers, these little tubes have been on here for years. I'm waiting for this dude. Hmm. Huh. Hmm. You guys want to do that? Well, just a Oh, I can do it. Perfect. I'm thinking we put a little tube right here at the knuckle. It's gonna. This thing is for this knuckle and this knuckle, the two distal knuckles of the index finger. And I'm thinking if we put a tube here, kind of feed it through like a fishing line feeds through one of the tubes of a fishing pole, like one of the rings. If we put a tube here, the string would be making no contact with the cloth. I'm concerned if the string makes any contact with the cloth, it'll rub back and forth and cut it, and or destroy the string. Um, so a little tube here of Teflon tubing would be good to remove friction, and then maybe one more tube here, and we'd be good to go. Just want to make sure it's very smooth here. It's hard to put upward. Okay. That was it. Yes. Okay. This is it's working out great. I like it. Everything looks good. I think we might have nailed it. It's much different than I was envisioning. But sometimes, like, when you go to actually build it, that's what happens. It's different when you're building it compared to just visualizing. Sometimes, to some degree. Okay. Oh, not this stupid thing. Okay. Oy vey. Come on. Okay. Definitely looks like I'm working on a robot. That's different. Usually when I work on the robot, it doesn't look like I'm working on a robot. You're getting to see hands and motors and load-in cable. Things look progressed more than they used to. I was like just building a robot bone or something. Okay. Creating one more tie down point near the base where I put the tape now. Looks pretty solid. That's it. Solid. What the heck am I missing? Sorry, okay, yeah. Let's see. Alright, I think that's a good stopping point. So, just to review what we got done, I attached the little return spring. I ran it through the, I sewed it off at the top here. I tied off a orange string to it. That's some PE fishing line. What type is it? Hold on, let me show you. 10-pound test, 0.12 millimeter Hercules PE fishing line. Okay, so I ran that off my tension spring. The tension spring looks to be about half a cent, 4/5 of a centimeter, maybe something around there. The total draw distance is this amount here, from the tip of the boating cable to this. The spring will pull all the way to there, and so it will have about 0.75 inches of draw. Now it enters the boat-in tubing, ties off with some fabric tape to the bone sleeve, sewed it off there. You can see where I did not finish tying off my loose end here. So it's sewn here and here, pinned down to the sleeve, and then you can see I ran it nice and loose from there all the way down to the index finger, or then tied it down to the index finger with the fabric tape. And now this will go through a little tube ring here on the finger, and then it will tie off to the distal tip. And this thing will keep the finger wanting to be super straight like that. So when the motor causes it to clench or grasp, as soon as the motor switches off, it's going to want to pull it straight again. So the motor will just turn off and the spring will bring it back straight, like that. That's the theory. So I haven't finished tying off the spring, but I feel like we made great progress. The next time I'll get rid of all this loose string. Like when you tie stuff off, you don't want to leave loose string like this hanging, because that eventually gets in the way and it's very annoying to work around. And we're starting to get a lot of that, so we got to tie that off. I don't even like to cut it short like this. That's kind of a lazy way to do it. It's better to actually pull it through the fabric and then cut it flush with the fabric, so it's completely hidden away. But you don't want to also cut it real close to the knot, because then the knot can untie. So you want to leave a little bit of gap, but then pull it underneath the fabric to hide it. So yeah, boys. In fact, it's good to put a little bit of super glue on every knot so it doesn't gradually untie over time. I try to do that a lot, but I haven't done it consistently, so I'm kind of gambling by not doing that. Yeah, it's going pretty good. I'll give you guys a close-up of my Archimedes pulley system. So you got here the output shaft of the motor, which turns this turn-in-place winch. And then that down gears at 2.77 to 1 with that winch. And then it comes out through this tube here, it comes down and around, through the tube, through here, and then it comes out the tube right here, and then it wraps around these pulleys. We got a pulley here, double pulley here, double pulley here, double pulley. 3 double pulleys and a single pulley. And so it makes all these turns, and this down goes at 16 to, down gears at 16 to 1. So 16 to 1 multiplied by 3.77 to 1 is 44 to 1. 2.77 times 16 is 44. So 44 to 1 down gearing is the total amount of down gear. After it comes off those pulleys, it then ties to another string which goes through this tube. Then it connects to a little ring which distributes through a tube, or a string that goes through that ring. The ring is just the eye of a fishing hook. And then it goes into these 2 tubes, which lead to each of these 2 joints. So this fishing, or this first motor, this first actuator is going to actually actuate the distal 2 joints instead of just one. It's going to do the 2. But then we'll use a different motor for this joint. But one motor can do the final 2, because those pretty much move at the same time. Like, you can see, like, very rarely do you have a case where this bends down like still straight. But yeah, it can do that on here because I created this slip joint with this eye of a needle, eye of a fishing hook, I mean. Because this will pull regardless. And so as the fishing hook eye raises, if something were locking up the distal joint, this one would still move. So it would be able to do this, like how you hold a pen. It would be able to do that. So yeah, we crushed it, boys. We crushed it. I haven't tested any of this though yet. I mean, I tested the version 1 Archimedes pulley system, but not the second version. But it should be good. Alright, boys, I'm gonna call it here.